Hi, today we are going to look at application of differentiation and integration to kinematics. The question we have here reads, a particle moves with a speed of v, which is -5 plus 3t squared meters per second through a point O. S is 10 meters when t is 0 seconds. Determine, part A, an expression for its displacement s after t seconds. Now I want us to move in parts, so let's begin with part A. We are told to form an expression for the displacement after t seconds. We need to take note that when you're given displacement s, we can determine the velocity by differentiating displacement. Similarly, we can also get acceleration by differentiating velocity. Now, the reverse of this process is integration. So, if you want to get velocity from acceleration, you integrate acceleration. And for us to get displacement from velocity, we simply integrate velocity. So, in this question, we are told to form an expression for displacement s after t seconds. And the expression we're given here is for velocity. And that means for us to get displacement, we are going to integrate. And we are going to integrate velocity. So, displacement is, that is, we integrate -5 plus 3t squared with respect to t. This should give us -5t plus t cubed plus c. So this is, we increase the power of t by 1, so that is t cubed, and then the power divides the term, that is, we divide by 3. The 3's will cancel, and that is how we remain with t cubed. And then you must add a constant c. Next, we are also told that the displacement is 10 meters when the time is 0. This information here is important in that it will help us determine the value of c. So for this equation here, we have s is -5t plus t cubed plus c, but s is equal to 10 meters when t is 0. So substituting these here, we'll have 10 is equal to 5 times 0 plus 0. So because t is 0, this term and this term will disappear, and therefore c is 10. And if c is 10, then that implies that the displacement s becomes, so we're going to rewrite this with the value of c, which is 10. So we have -5t plus t cubed plus 10. Well, let's move to part B. Determine its displacement after 2 seconds from point O. So that means we are going to find the value of s when t is 2. So we have the time is 2 seconds, so we substitute in this equation for displacement, and therefore we'll have -5 into t, which is 2, plus t cubed, that is 2 cubed, plus 10. This is -10 plus 8 plus 10, that gives us 8. So we have the displacement is 8 meters. Next part, let's see. Determine an expression for its acceleration after t seconds. So for us to get acceleration, just to refer back to what we had said earlier on, to get acceleration From velocity, we'll simply differentiate the equation, or rather the expression. V is -5 plus 3t squared. So acceleration A is equal to the derivative of V with respect to t, and that is, when you differentiate -5 plus 3t squared, that gives us 6t. And if acceleration is 60, I think that is what we are required to get in this part after t seconds to mean our answer should be expressed in terms of t. And then we have the next one, its acceleration after 10 seconds. So we need A, which is already given us 60, but when t is equal to 10 seconds. So that's very simple. Acceleration is just 6 times 10. The time t is 10. So this is 60 meters per square second. And finally, we're required to get the time t when its speed v is 0 to 3 decimal places. Just a reminder, v is -5 plus 3t squared, but for this case now v is 0, so that means you're going to have -5 plus 3t squared is equal to 0. That means 5 will cross to the right hand side and we'll have 3t squared is equal to +5, and therefore t is 5/3, that is t squared, sorry. And finding the square root on both sides, t becomes approximately 1.29099,445, but because we are asked to leave our answer correct to 3 decimal places, we will further approximate this as, so t is again approximately 1.291, and that is to 3 decimal places. And that is it for this question. Thank you for watching. See you in the next video.